Guys, girls, good afternoon. And we're back again with our very troublesome 8800GT. This is the one we were looking at yesterday that basically had close to a short circuit about 2 ohms from here, and the chip and the Mosfet was getting hot. And if you remember, if you watched the last video, I sort of went off on a tangent a little bit and said, let's see and look at the data sheets of these, see what we can learn from them. And we did. And at that point, I got slightly, when I watched the video back, I was slightly confused myself. I mean, sometimes even I get confused with this stuff. And I think I probably didn't explain those data sheets very clearly. So I'd like to do that now. If you saw it yesterday and you knew what I meant, then just skip over this for a few minutes and we'll carry on, because I have some more interesting news to tell you about this graphics card. But for now, anybody who was a little bit confused by, or just would like to hear it again a little bit clearer, let's talk about these data sheets. So first of all, let's actually have a look at the data sheets themselves. Okay. Right, this is the data sheet for the Mosfet. Now remember I said, oh, this is a Mosfet, and I sort of said, oh, this is connected to the coil and this is connected to 12 volts, and I didn't really clarify why I knew that. But when we look at this, it actually tells us that this is a dual Mosfet, dual N-channel Mosfet, which means it contains 2 Mosfets inside, and they're both the same. They're identical, they're like identical twins, yeah. And if you have a look here, we can see what we've got. This is Mosfet number 1, yeah, and the drain connects to here, okay, and the source is source 1. It's down here, pin 3. These chips, by the way, always number the same way. So where the dot is, that's pin 1, 2, 3, 4, 5, 6, 7, 8. So you go around in an anti-clockwise direction. That's true really of pretty much all chips. So there's something else if you didn't know, you've learned. But we'll talk about components in more detail. But anyway, there we are. So drain 1 is these 2 pins, source 1 is number 3, and gate 1 is number 4. And then we have Mosfet number 2. So in this case, drain 2 is here, these 2 pins. Source 2 is the top one, and gate 2 is there. And that's what we have. Now, if we look at the RT9259, this is the driver chip. And here's a little typical application circuit. And you can be pretty much as sure as damn it, this is what's on your board, yeah? So, let's see what we have. This is the controller chip, and here you can see 2 Mosfets. And these 2 Mosfets are the ones in that AO4812. That's what they are. You can see power comes in. This is the first Mosfet. This is the coil. This is where your voltage out comes. Second Mosfet to ground. And remember I told you about this. You have an upper Mosfet and a lower Mosfet. Yeah, high side and low side. And this is typical. This is we've seen this a few times now. So this chip here can switch on these Mosfets in turn, yeah? So it switches this one on, and it charges magnetism into this coil and puts a bit of power into the capacitor. When it's got enough power, it switches this one off and switches this one on, yeah? And the power sort of circulates round and on and on and on. So it's switching very rapidly between these 2, and by the width of, the amount of time each one is on for, it controls the voltage here. It has here feedback. This is the voltage sensing. So this pin, by this, the controller chip knows what the voltage is. And you notice here, from the junction between the 2 coils, one called phase. I'll tell you what this is. Upper gate is the drive to the high side, upper side FET. It's fairly obvious. Lower gate, low side FET. We've discussed how these switch. Phase connects them between the 2. And what phase is for? It basically tells the chip when this MOSFET is switched off. And the same with this one. And now you might think, hang on, Rich, it knows when the MOSFET switched off because it tells it to switch off. Here it says switch off. And that's true, but a MOSFET is imagine like a physical switch. You push the button, yeah? And there's a finite amount of time between you pushing the button and the contact inside actually making the contact or breaking. And that amount of time, there's a lag, and it might be microseconds, but it's still there. And the same applies with an electronic switch like this. When the controller switches this off, it can't switch off instantly. It's a slight lag. And the same with this one. And that's what this phase is saying. This is saying to the chip, switch off. Yeah? And then it's watching phase till it sees it has switched off, and then it can switch this one on. If it didn't do that, it would say switch off and switch on instantly. And it's assumed, well, that one's off, so this one can go on. But it's not. This one can't switch off straight away. So effectively, for a very short period of time, you've got a short circuit. This is still on, switching off, and this is switching on, yeah? So that's what phase does. It just, so this chip knows that the thing's switched off, it can switch this on. So hopefully that's quite clear to you. So what we're going to do now is go back to our circuit, and let's see if we can see this arrangement on our circuit board. Okay, so we're back on the microscope. We've got the meter and we've got a bit of paper here. So let's see if we can look on our board and figure out how this relates to the datasheet. And let's just draw it so we know. We've got 12 volts coming in. Yeah. This is the high side MOSFET. And this is the gate, source, drain in, source out. And this is going to the controller chip, yeah? And this is upper gate drive. So this signal turns this on and off. From the other end of this MOSFET we have the coil, okay? And this is out, volts out. And from here, remember, there was a connection to the controller called phase. Okay? And then from here we have another MOSFET, and this one should go to ground. This is your lower gate. Yep. Again, this is going to be drain, this is going to be source. So let's see if we can see that on our board and put that into what we have. We can see, is that what we have? So the first thing when I looked at this, I was saying that this point here was connecting to the coil, yeah? And that's because you can physically see it's connecting to the coil. I mean, if you couldn't physically see it's connecting to the coil, we can go from here, then we can go onto the coil, yeah, and it's connecting to the coil. Doesn't matter which side of the coil, it's connecting to the coil, yeah? Okay, so we know from the data that's drain 2. And because the drain is connecting to the coil, it's a drain, it must be this one, because the other drain should be connected to 12 volts. So that drain, those pins 7 and 8, remember I said it goes 1, 2, 3, 4, 5, 6, 7, 8. So 7 and 8 is the drain, and we've got a coil there, so we're pretty sure it must be this one. But to be certain, if it's this one, then the source should go to ground, yeah? So let's have a look. So connect to ground, and the source was there. Yeah? The next one was the gate, so that's what drives it. That was this chip. Okay, so we know that. So we know this is pins 7, 8. We know this is pin 1. Yeah? And we know that's the gate. Pin 2. Pin 1. Pin 7, 8. Right, so we've identified that now. And to be absolutely certain, you remember from this drain here, we have a connection to phase, yeah? They've actually connected it a different way, but it doesn't matter. Well, let's do this one, then we'll talk about phase. I can see it, but I just want to make sure that you can see it. Let's look at the other MOSFET first. Okay, so the other MOSFET, you should have drain coming in, should be 12 volts. Now, the other drain is down here on pins 5, 6, yeah? That's 5, 6, and I'll go on to the 12 volt supply coming in. Yep, so that is 12 volts, so that's pins 5, 6. Okay, the source, which will be pin 3, should connect to the drain of this one. We can check it that way. And yeah, it does. Let's have a look. See, pin 3, yeah? I can see it does already. There. Okay, so that source is pin 3. And now we can also very clearly see now, from pin 3 to the controller chip, this is phase. There. So we can see we exactly have that. And that's basically what we have on this chip, so we can see straight away. The only other pin we haven't used is number 4, which is that gate there. And that's that. And that's what I was trying to explain to you yesterday and got myself a little bit tangled up. So, yeah, okay. If you spent a little bit of time just watching that bit of the video, hope you've enjoyed that and learned a bit from that. And this is something we're going to do quite a lot on repairs, to track out a circuit board so we know what we're looking at when we don't have a schematic. Okay. Well, back to the interesting stuff. So, yesterday I said, if you remember, we measured down here on the top of this capacitor, and we got the lowest voltage here, and we basically know that the short is here. And I sort of said, okay, well, we'll take the chip off and let's have a look. But then when I watched the video about myself, I thought, actually, Rich, there's two sides to every story here, and you haven't told both sides. And there's definitely two sides to this story. And the other side to the story is this side of the board. Okay, let's get a bit of focus on that. So this is behind that GPU. And what do we have here? We have a lot more capacitors. And I thought, well, I'll bet some of these capacitors are also connected to that voltage rail. And they're underneath the GPU, and they're very close, so you probably couldn't see the voltage drop here compared to the other side. You probably couldn't see any difference. And maybe one of these capacitors is actually the short, not the GPU itself. So this morning I just had a bit of a probe around here, just seeing, and yeah, I could find some capacitors connected to that short circuit rail. But all of a sudden, the short circuit had gone. And I thought, well, that's a bit strange. But do you remember when we first looked at both these boards? And I said, when we found this short yesterday, I'm sure that wasn't there the day before. I need to check my old recording. And I wasn't cracking up, and that short circuit wasn't there before. And now it is. So I measured it, and there wasn't a short there. It was reading 300 ohms, the same as the other board. And then I left it on one side. I was just doing something else, and come back, and the short was back. So I then basically under here, I flexed the board a little bit, and just a touch, and I went back and had a look. And by flexing the board, I could actually get rid of the short. So I thought, oh, that's great. I'll do the work I need to do, because remember, this is a hobby really. I'll get my work done for the day, and I'll come back and I'll have a look, and I'll stick this in the machine. Now the short's gone, and let's see what it does. And when I came back to it, the short was back again. And it's just been sitting there. So it's intermittent. The top model is intermittent, and since then I've been flexing this board around, and I can't get rid of that short again now. But the short disappeared while I was actually probing around down here in these capacitors. There we go. Now, this sort of fault is a bit unusual. Normally, if you've got an intermittent problem, it's an intermittent open circuit, not an intermittent short circuit. So it's not that common. And if you're thinking, yeah, well, you know, the balls under that BGA, you're losing the contact from the circuit board when you flex it. That's possible. And I guess if you happen to be losing contacts on the pins that just also happen to be the ones on the voltage rail that's got the short, then yeah, that would do that. You might get, you know, flexing to go away, it'll come back. But that's a bit coincidental, don't you think? You've got a short on some voltage rails on the GPU, which will no doubt be using not just one ball, one pin, but a number of balls. And by flexing it, you can manage to break the contact on those same balls that have got the short circuit, and flex it back, and they go back again. And that seems a bit unlikely, don't you think? I mean, anything could happen, but it seems a little bit, don't think so. Now, another common cause of short circuits on circuit boards are these sort of capacitors. These are called MLCC, which stands for multi-layer ceramic capacitors. And these are known for having cracks, microscopic cracks in them, often caused by flexing boards and mechanical strain during the soldering process and otherwise. And when you get a crack, you'd think, okay, it's got a crack through it, therefore it's open circuit, but it doesn't. It goes short. I think inside, when it comes to multi-layer ceramic capacitor, you've got lots and lots of layers of conductor and lots of layers of insulator in between them. And by flexing these, I think you're actually shorting the conductor between two layers, and therefore you get a short. So I'm thinking now, it's more likely I've got a capacitor down here that's causing the problem. Which sounds great, but the real problem with that is, how do you find which one it is? We can't get enough current into the board to get anything hot, but we're going to try again and feel on this side. If we're dead lucky, we might just find it. If that doesn't help, then I'll give it a good. Let's have a good physical examination. Let's see if we can see anything that looks vaguely distressed. I mean, maybe that will give us some hints. The capacitors are in this area because I checked them before, but we'll check again and we'll try and figure out which ones they are that could be involved. So that's the next thing. The other possibility is we take the GPU off the board. So hopefully there's nothing else connected to that voltage rail, and we can now be rather cavalier about this and stick more voltage down that rail, trying to find the short. In the hope that you're not going to blow something else up because there's something else as the GPU. The only problem I've got with doing that, I don't have any issue with doing that, apart from I can't find a stencil to rebuild this GPU. I've had a bit of a look and I couldn't see one. And that means I'd have to rebuild it by hand, which is very time consuming, but okay, maybe. But we can also, I had a look at these GPUs, you can buy them for about €8, they're not expensive. So it might be that with both these cars, if we can prove the GPU was a fault, I'm not sure it is on this one, but we'll see, that we might just buy a couple of GPUs. I mean, by the time we've done that and the cost of the boards each, by the time we fix them, we probably spent what they're worth. But don't you think it'd be educational? I mean, let's face it, educational experience is worth a lot more than money. Yeah. Okay, so let's have a look. I'm going to first of all, yeah, this is the board, the one with the letter H on. Remember, so we know we're talking about the right board. To make this easy, I'm going to tag a wire onto the end of this coil, whichever end I can get. I'll probably get at this end a bit easier. Oh, or I'll tag a wire to the top end of this FET, because that we know that goes to there. It's a bit easier. So I'm going to stick a wire on, and the reason I'm going to stick a wire on here is so that I can connect the meter probe and not have to think, well, I'm trying to hold the wire on one side, meter probe on one side of the board while I'm trying to work on the other side, because that's a bit of a pain in the backside, to be honest. So what we'll do is let's stick a bit of wire on here. I'll try on the coil. If I can't get a coil, I'll get it onto the FET. So first of all, a bit of flux is what we need, yeah? And then we're going to get a bit of solder. This is leaded solder. It's much easier to work with. But this is going to be a bit difficult for me because I'm trying to look at the screen to one side while I'm trying to solder, and I'm in my own way, if you know what I mean. So I'm probably going to make this look like I don't even know how to solder. Let's have a go. Let's get so you can actually see where I am on the board. There, okay. Let's see if I can actually do this looking sideways. I might not be able to. Did we get any solder? No, we probably didn't. Let's get a little bit more. Try it again. Solder doesn't seem to want to take onto this coil, so I'm trying to do this also so you can see what I'm doing, and a lot of factors don't help. Okay. Now I've lost the camera. Sorry about this, guys. In the end, I'm probably just going to solder this on myself. I'm not going to try and do it on camera. But I think we've got a bit of solder on that. Let's get out a bit of wire. Just a bit of wire, nothing else. And let's see if we can stick that bit of wire onto the end of this coil. Yeah, I got it. Believe me, I can actually solder it. It's just normally I'm looking forwards and to see what's on this recording. I'm looking to the side, Let's just make sure we didn't short to here. We might have shorted to there. I'm not happy with that. I'm not happy with that. I'll shut up a bit and I'll try and do this where I'm looking. Maybe that point is actually connecting to ground. Oh, yeah. I think I'm just, again, slightly confusing myself. I'll bet this point here is ground. 2.3, 0.1. Yeah, so although the meter's beeping, I'm listening to it beeping, I'm not reading it. That's not shorted. It probably wasn't before. Okay, so we tagged a bit of wire on there, yeah? What we can do is now, you can't see me, but I'm just fastening the black meter probe to the other end of that wire. There we are. And I'll just check to make sure that in actual fact, yeah, 2.4. So we've got a good contact. Okay. So let's have a look now around these capacitors. And because I've tagged the wire onto where the 2.4 is, this should read 0 because I'm measuring the resistance from the coil to here, not from ground yet, just to save any confusion. So we know it goes there. This, you see, when I read to ground, I actually see the 2.4 because I'm measuring from the end of the coil, not to ground. But we know there, that's where it goes to. It goes on that capacitor. So look at this one. Yeah, it's on that one. It's on that one. It's on that one. I think it was also on a couple more up here. It's on that one. I think it was on this one. .6, maybe it isn't that one. Oh yeah, this was a 2.4s there. No, that one will be, remember we had one supply rail to this GPU that was about 0.5, 0.6, that's that. So it's not there. Is it anywhere else? It seems to be in this area. Mostly. Oh, that's the 57 ohm supply, you can see there. 2.5. So it mainly seems to be on these ones down here where I'm reading the 0. There. 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 So a little bit further in. It's there. Not on that one. Okay, it seems to be in this area. Without actually sitting and going through the whole board, it seems to be in this area where that is. So what we're going to do is now, we're going to stick into this off the bench power supply, the 1.1 volts or so. I'm not going to put the power supply so you can see it this time. I mean, you know what it looks like. Sorry I had to interrupt the video there. I just had a customer who brought me some disco lights to repair. So actually that could be something interesting. It's a paid repair, but tomorrow I think we can, yeah, let's have a look at them and see what's going on. So back to this one. This is quite interesting. There's definitely something going on here, and it's just very difficult to pin down. I have connected the voltmeter to the bit of wire which is feeding the power. You know, remember we soldered a little bit of wire, yeah, to the end of the coil. By flexing this board, if you watch that voltmeter, can get the voltage to change, and I'm sure the reason the voltage is changing is because obviously there's a little bit of voltage drop down the wire, and it's by doing this I think I'm making the thing draw more current. And sometimes if I just leave the power on and wait, I can feel something here getting warm. It's not getting hot as such, but there again, I mean, we're sending like 0.7 of an amp into here, which is not a huge amount. Look, and now the voltage has gone up because I've lost it again. So I have to just a little bit of pressure in the right place here. And I'm using my little finger because generally that's the most sensitive to temperatures. I'll just try maybe the side of the thumb. You'll find that your fingers, I'm sure you know this, some fingers are more sensitive than others. Flex this again and get it to actually, that voltage to come down a bit. It's so intermittent, it's a real swine to find this one, it's a bitch. No, I can't get it to do it now. Let's out of interest, let's just put this back onto resistance mode. I've just disconnected the power supply. I'm just going to check the resistance again on the end of this coil to ground. No, we still have the short. Okay, it's still there. Connect it back up again, put it onto voltage range again. Just measure the voltage again. Yeah, I'll try and just wedge my voltmeter onto the cable. Make sure I've got a good contact. Yeah. And let's see again if we can get that voltage to relower. It's actually we're just going a little bit higher than we want. Just. There's definitely something in here, something going on. Now I can feel it. Well, the best thing we can do here is start to desolder some of these capacitors until we can see if we can find out which one is the one that appears to be causing the problem. If we've desoldered all the capacitors on this voltage rail and we still have a problem, then I think we have to desolder the GPU. That's one way. I guess the other one is to desolder the GPU. I can feel something under this finger. It's, you know, when you've done this so many times, then you start thinking you probably warmed the blood up yourself with your fingers. Let's just cool that area again with a cooling spray. No. Okay, let's decide we're going to get nowhere this way. So I think what we'll do is we'll start to remove some of these capacitors that we know on that supply rail and see if we can make the fault go away. Okay, so I've connected the end of the black end of the meter back to this bit of wire, so just ignore that resistor. I could take it off there, but it's helping to hold the wire on the end of the meter probe. And the first two capacitors we're going to try and remove are this one and this one. You can see that one end of each of these capacitors is connected to the coil, so it's on that voltage rail. So these are going to be the first two to get rid of. And let's see if we can find where, if it's one of these two. Something here was getting warm. The question is what was it? And the answer is I don't really know. It was so hard to determine. It also seemed to be somewhat well, we know it's an intermittent problem. So these capacitors have to go. Normally I'd take a photograph of this area of the board first, which helps me when I come to put things back together again. But in this case we have another identical unit, so really we can use the identical unit to actually you know, we know what goes where basically. So these two capacitors have got to go. The way I would normally do that, first of all, I can use hot air for this, but I tend to find when you're using hot air, you're heating up the whole area and you're kind of melting other capacitors, and you probably don't really want to be doing. This one's going to be very easy to get at, so let's go with that one first. So what we'll do is first with this one is we put some flux on the capacitor here. Let's have that one as well at the same time. Let's flux on that one. What I'll do now, I'm using the BC3 tip on the soldering iron, which is a big chunky one. And the reason I'm using this is because I can get a lot of heat into the capacitor while I'm actually working. I'm going to try now just to get in position so I can actually look down the microscope directly. Well, you can see this on the screen because it was making it very difficult for me to solder when I'm trying to look to the one side. So what we do is first is we're going to get a bit of solder onto this capacitor. This is leaded solder. What this is basically doing is it's forming an alloy with the existing lead-free solder and lowering the temperature, the melting point for solder. So we'll do that, and then we'll get some fine tweezers. Let's see which of the finest tweezers I have in the little bag of bits here. Find my favourite ones. Okay, I have them. And these are my tweezers. So basically now I'm going to try and heat up both sides of this capacitor at the same time and get it off the board. To do that, the easiest way is to get a bit of like a blob of solder on the end of the iron, yeah? So it actually makes a very good contact. Use the tweezers. Let's see if we can get enough. There we go. We have it. Okay. So that's one of the capacitors off the board. Came quite easily, as you can see. Let's go for the other one as well. Oh. The capacitor's now stuck on the end of my tweezers, of course. What do you expect? Okay, let's put that just safely on one side, and then let's have a go at the other one. Let's see if we can get this one off easily. There's a bit more room coming from this side. Might be easier, but let's try from this side first, because the bit more room also means I've got a bit more room for the tweezers as well. So that also would help me to some extent. Where are we? We've lost where we were on the board. We're over here somewhere. Yeah. So this is our other capacitor. So we're going to try and remove this one. So again, let's get a blob of solder on the end of the soldering iron. We'll get the tweezers in. This one's stuck on the end of the soldering iron. Come off. There she is. Okay, so that's the second one of those capacitors off. So what we can do is now is we can have a look to see whether or not our short circuit has actually gone away. So let's just put this capacitor safe with the other one, because obviously we're going to have to be putting these back on at some point. Depending, I'm assuming if there's a faulty one, there's only one faulty one. I'm just talking off the camera, but I was having a bit of trouble getting that capacitor to actually come off the end of the soldering iron. Right. What's happened to the camera? Guys, I'm really sorry about that. I don't know what happened there while I was desoldering those, but the microscope froze basically, and we lost. Well, I'm sure you could hear me, but you couldn't see what was happening. So those two are off. I've put them on one side safe, so we don't lose them. And what we're going to do is now is have a look if we still have this low resistance come short circuit. So first thing, let's just clean off where we were soldering. Yeah. This is isopropyl alcohol. Definitely worth buying yourself some of this. Don't try using anything else really. You know, rubbing alcohol and whatever. Just get this stuff. It's better, much better. Let's just get a bit of kitchen roll and wipe that off there. There we go. So they're off nice and clean. So let's have a look now and see whether we have. I'm measuring the resistance from the coil again to the capacitor. So it's definitely connecting to the capacitor. Yeah, and it's still measuring to ground. The other end of this capacitor is ground, and it's still measuring 2.4. So removing those two didn't help us. So now we need to find some more. So this one, second one in, yeah, it goes to that one. It goes to that one. That's 1, 2. That's 3. That's 4 in a row. The other end is ground, obviously. I'm measuring from the course, that's reading 2 point whatever. That's 4. So let's remove those 4, or say do 2 and then 2, and let's have a look again to see if we've got rid of this short circuit. I hope this time that the camera on the microscope doesn't freeze. I have no idea why it did that. So once again, just bear with me. I'm going to actually look directly down the microscope so I can see what I'm doing, because it's far better than trying to work on the screen, which is now off to one side. I'm not bad at working on the screen directly in front of me, but I'm not very good on when it's off. You know, when I'm looking through sort of 90 degrees to one side. So just before we do that, let's get a bit of flux on. So the flux always helps due to desolder, and let's get a little bit of solder onto the ends of these capacitors again, so we know that you know, basically reducing the temperature. Now you might wonder why I'm working with this big chunky soldering iron, but it's actually far better at doing this sort of work than the fine point. You can try yourself. Obviously this is a technique only you can learn, you know, and you find your way, but for me the big chunky iron is the better tool to use for this sort of work. So again, we're going to remove these. So there's a bit of solder on the end. I'm sure you can see on the end of that bit there's actually some solder that I can get in here, and we can move it. Yeah, 1. That was the most fiddly. These will come easier now. So this one's actually stuck to the end of the body pad. This capacitor has actually stuck itself to this pad and doesn't want to come off now. Okay, sort of swine. Sometimes these things happen, you know. If we can't reuse that one, don't worry about it. First of all, it might be the faulty one anyway, if there is a faulty one, and secondly, if we measure the value of one of the other ones, they're all going to be the same anyway. Yeah, it's off there now, but it's now completely stuck onto the end of the soldering iron, so it's not going to be a lot of, it's there, it's come out, we can see it. I'm not quite sure it's very much appreciated, that sort of abuse, but there we are. We have 2. Let's go for the third one. A little bit of solder on there. Get in again, up against the component. She's off, yeah. And the last one, exactly the same technique, up against the component. She's off. She's off. Again, that one's stuck on the end of the iron again. It's off. And it's stuck on my tweezers. So we now have all four, 1, 2, 3, all four capacitors there. We'll put them safe on one side, and then we'll clean up the area where we were working, and we'll again have a look to see if we've got rid of this short circuit. So first of all, I'll just tidy these up. I've just got a little box over on one side there. I'm keeping these things. You can imagine, in reality, these are tiny. There's another one. I'm also having to swap between wearing my glasses and taking my glasses off to look through the microscope. So that's also a bit of a nuisance with this. So again, we have the other one, and I'll just put that one safe again. We'll get a bit of the isopropyl. Something stupid on the screen. I've also noticed, by the way, that when I'm focused through the microscope, you are slightly out of focus on the screen. I'll try and adjust the actual camera for that, but you appreciate I'm having to get this into shot, focus myself to work. So unfortunately, you guys are the ones who are getting the blurry image. But sorry, I need to be able to see what I'm doing. Okay, so let's clean up that area. Get a little bit of came off quite clean again, but we can clean up the area before we replace the components. So again, let's go from ground. Oh, my resistance meter isn't working because yeah. Okay. Right. Always worth, just before you measure anything, just check your meter. You can imagine that's going to save you some time. So that ends the ground. That's the 2.3. No, sorry. That ends not the ground. That ends the end that's connected. Rich, start again. Okay, I'm measuring to ground there. Obviously the short's still there. Let's measure to the actual end of the coil we're interested in, okay? But we know the short's still here. That ends now ground. So this short is still here. So we still haven't found out where it is. So what do we do now? We look for some more capacitors connected to that voltage rail, and that's really the only way we're going to do this is to identify all the suspect capacitors and just take them off. If we run out of capacitors before we run out of short, then we know full well that the GPU is coming off next. That's not on the circuit. That's not on the circuit. I'm going to make this easier. I'm going to leave you on the screen. I'm going to look down the microscope. I can see much easier what I'm doing. Not that one. Not that one. You see, that's on a high resistance. Not that one. Not that one. So they're all on a different voltage rail. That's on the 57 ohm rail. Sorry, I lost the microscope camera again then. I'm not sure. It seems to be when I'm soldering for some reason. Very strange. Maybe some sort of interference on the USB cable, I'm not sure. Anyway, we've removed all those capacitors and we still have the same problem. But definitely if something was getting warm, I could feel something, it was in this area. So I think what we do is here is have another look around that area and see if maybe there's some other capacitors that we haven't found yet. Let's have a look. So in fact, I can even measure across the capacitors. 2.5, that's on the voltage rail. I'm doing it this way rather than 1 meter on the coil because I thought maybe it's confusing some people, and some people say you're not quite as clear. So let's show you what I'm doing. But this is the same as putting the black wire, the black meter lead onto the wire that I've soldered to the coil, and going I'll show you that. That way we see the 2.3 across the capacitor. If I connect the black wire back to the bit of wire we soldered to the coil on the same capacitors, one end is connected to the coil and the other end is to ground. But if you find that confusing, don't worry about it. We've done it this way as well. So we know for sure these three capacitors are on that rail. Let's have a look at the other ones a bit closer, see what we have on these ones as well. That one is by the looks of it. Now these are reading 2.7, 3 point something. I think that's a different voltage rail. That is 2.3. Oh yeah, it does. I've just not got very good contact. So those two are. That one is. So it looks like we have quite a lot of. That one isn't. That's the 0.7 volt rail. That's the 0.7 volt rail. That's the 0.7 volt rail. Okay, so we've identified these three across here, and we've identified the ones up this side as well. This one, this one, this one, this one. That's 4. That's on the lower voltage rail. So we've got 3 here and 4 there that are all on the same voltage rail. I'm working on the assumption here that all these capacitors are actually the same value. So I'm just sticking them in a little pile. I don't think it's critical, but you know, you can make the wrong decision. It was interesting that, you know, I said there was 4 up here, didn't I? 1, 2, 3, 4, and that one looks a bit more brown. Yeah, that one looks a bit more brown than the other ones. Let's see again if we can just get the meter leads directly across that and make sure it was on the same. Yeah, definitely that one. This one looks a bit more brown as well, so maybe, you know, that's nothing. Anyway, they've got to go, haven't they? They've all got to go. We'll take the 3 off across the bottom first, and if that doesn't show us anything, then we'll work our way up the other side. Hopefully we're either going to find a short or run out of capacitors fairly soon here. Somebody again on the forum, so not a forum, somebody on the channel is watching and says, you know, Rich, that's not really the way to do that. There's an easier way, there's a better way. Then yeah, I mean, let's hear from you guys. I'm trying to teach, but I'm sure there's going to be people watching this who are better than me, or people who just have different knowledge to me, and you know, they've come across things in the past I haven't, and maybe have a better suggestion how this should be done. So anyway, let's get some more of these capacitors. Let's get them off there. So again, much the same. I hope the microscope doesn't go off again this time. Flux. These 3. Same technique. Bit of solder on both ends, and then get the soldering iron against the component. Okay, bit of solder on both ends. Tweezers. Okay, let's get in there. Okay, so we've taken off the middle one first, doesn't matter. It's got to come off anyway, so off it comes. Again, we ended up with one capacitor stuck on the end of my tweezers there. Another thing with this microscope, by the way, I have a much wider field of view, so I can see in areas that you can't, which is a bit unfortunate. But again, I'm not really sure exactly how to get around that. I may have a play with the camera, see if I can actually zoom it out a little bit more. Let's have a little bit more solder on a little blob on there, yeah. And let's go for the next one. That was nice and easy. Again, it's stuck on the end of my tweezers, so we need to just take that off there. Okay. Surprised how well these stick, you know. I mean, actually getting anything to lie down can be a problem. Okay. I don't know if you're in your view, you can see them here where I've just dumped the capacitors for now. So those two are off. We've got another one in this row across, and then once again we'll see if we've got rid of this short, and if not, we'll go up the other 7 and see if we have now got rid of this short, and if not, we'll look for more capacitors again. That's off. Once more, stuck on the end of my tweezers. So if anybody knows how to stop that happening, let us know. It's very, it'll stick to the end of your tweezers, then it'll stick to the end of whatever you're trying to use to remove it from your tweezers. So, okay. Once again, we've removed some capacitors. What we need to do now is put these capacitors somewhere safe, because otherwise, when we clean up the area, they're going to go missing. I mean, I have capacitors, you know. I think I might have actually lost one while we've been doing this. It's not a problem. All we'll do is we'll just measure the voltage of the other ones, and so measure the capacitance of the other ones, and we'll know basically what they are. That's now stuck on my finger. There we go. And there's one more. Let me just look back through the microscope so you can see properly. It is one more there. So let's get rid of that one. Okay. Same thing as before. Looks like the microscope's still working this time. Bit of isopropyl alcohol. Just clean that up. And one more time we'll have a look to see if we still have this this low resistance come short circuit. Again, now let's see if I can actually use the screen this time, just to save me having to take the glasses off. That's the problem, you see, when you take your glasses off, I can't see the multimeter very well. Nah. Still exactly the same. There's no point in measuring the others as they really. We know it's still there. We know we still haven't got rid of this. I don't look like it was 102. It's just the reflection of the light. No, that's still there. So we now have these capacitors up here. These two I've managed to actually bridge together, as you can see. Not really a problem. Basically in 2.4, 3, and not that 4, and not that one. So first 4 up this side. You've seen the pattern forming here. Okay. Back to the microscope again. And let's see what we have. So we have the 4 up this side this time. Let's stick with this technique, because it's working. Just clean the end of the solder down a little bit. Can you see now why I use this big chunky soldering iron tip? Because it gets a lot of heat into what you want to get heat into. Let's try backwards on these two. Otherwise just turn the board around. Where were we? We're here. Now I've got this solder tangled up behind the board, of course. A bit on this end. Yeah, okay. Don't worry about those solder bridges, they're not going to cause a problem because they're coming off any moment. In fact, those solder bridges, if anything, are just going to help us get more heat into what we want to do. There we go. For once it didn't stick to the end of the tweezers. Come off. That one's well, oh no, it's off. I thought it was well stuck, but it's off. 4. Okay. Oh, the suspense. I'm going to measure this now. I can't wait. Let's see if we've actually now got rid of this short or not. No. So, even so, we still don't have it. And we're running out of capacitors, but we've got this far now, so we might as well just see if there's any more, because I'm sure I can fit something in this area that was getting a bit warm. Let's get these capacitors that are lying on the board, and let's put them on one side again so they're safe. Did that one just disappear, or did it just jump to a different place on the board? That's that one out of the way. Well, there was 4, wasn't there? And now we only seem to have 3. See, this is how you can lose these. This is why you need to have some spare parts. You can buy yourself, you know, 04, 02 capacitors is what these probably are, 06, 03, 08, 05. And you can buy whole kits of these for not very much money at all. I'm doing this, by the way, without the microscope again, and you can see that when I'm actually looking on the screen, it's very hard to pick them up. Did you watch the video I did on test equipment? This is why I told you that the USB microscopes are very good at for inspection and absolutely useless to actually work under. You notice when I was under the microscope myself, so one's gone somewhere missing on the board. Let's just get the paintbrush and just see if we can just knock it off there. No, it obviously went a long way. So we're still no further forwards. What we need now to do is again have a look around here, this area, and see if we can see any more capacitors on this supply rail. Let's see, can we do it with the yeah, let's try this way again. So I'm using the screen again. No, that's on the 50 ohms. That's 48. That's on the low ohms. The one from the 2 coils are on the same circuit. 55. That's perhaps reads short, but it's not an hour rail, so I'm not worried about it. I'm probably just touching the side of that other capacitor actually there. Yeah, that's on the 0.7, 0.8 volt rail. Well, where are these things connected to? Not sure about these because they're not reading 2.3, they're reading 2.8, and I didn't see any voltage rail that was that resistance, but they're not reading the same as across these, so as far as I'm concerned they're not connected to that circuit. Let me check those already. Let's have a look. Let's have a look. Yeah, that's the 0.8. As we see, that's the 0.8. Yeah, we checked all these 3 before they were all on the 0.8. 0.8. 0.8. What are you? Yeah. I can't see. They all seem to be concentrated here. If you ask me, and this is where, if anywhere, I could feel it getting warm. So I think now we can not worry about it. We can put these back on afterwards if we need. But I think the next thing now is going to be to remove this GPU and have a look to see if that actually gets rid of the shorts. So I'll get us on the BGA machine. We'll have to use a different camera while we're doing that, and I'm going to show you how to remove these. Okay.